Hello students, welcome back to today's class on fractions, decimals and rational numbers. In the last class we have discussed what is a fraction, what are decimal numbers, how to add, divide, subtract and everything. And we also started what are rational numbers, but we haven't discussed much on rational numbers. So let's try to continue our discussion on rational numbers, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. Right? I'm sorry. So, what are rational numbers? Before rational numbers, let's try to understand few fractional numbers, right? Positive fractional numbers. We know what is a fraction. 1 by 2 is a fraction, 2 by 3 is a fraction, 10 by 20 is a fraction, 10 by 100 is a fraction, right? In that we have positive as well as negative. So, positive fractional numbers like W1 by W2. All positive fractional numbers can in general be written as W1 by W2 with the condition W1 and W2 are whole numbers. W1 and W2 are whole numbers and that W2 should not be equal to 0. Right? So, one whole number by whole number, that will give you a positive fractional number. Let's say 1 by 2. Right? Let's say 2 by 3 or let's say 10 by 100, 99, whatever it is. But the only constraint in this whole numbers is W2 should not be equal to 0 because we know denominator should not become 0. We know denominator should not be 0. 2 by 0, this is not a defined number. That is an undefined. We cannot say what is the value. We cannot say what is the value. That is the reason it is undefined. Okay. So, moving ahead. In the same way, we also have negative fractional numbers. We also have negative fractional numbers. What do you mean by negative fractional numbers, right? The same W1 by W2 with a negative sign. With a negative sign, let us say minus 1 by 2, minus 10 by 999, minus 2 by 54. So, all these are negative fractional numbers. All these are negative fractional numbers, right? All negative fractional numbers can in general be written as minus W1 by W2 with the condition W1 and W2 are whole numbers and that W2 is not equal to 0. So, all these type of numbers are negative fractional numbers. We discussed what are positive fractional numbers and then we discussed what are negative fractional numbers. So, now let's move forward to fractions on a number line. Let's try to understand how to represent these fractions on a number line. All these fractions are nothing but they are rational numbers. All the fractions are rational numbers. I told you before in the last class also. Right? So now let's try to understand how to plot 1 by 5 on a number line. 1 by 5, what you do? You need to divide one part into 5 parts or one length, one unit into 5 parts and you take 1 unit from that. So, let's say 0 is here, 1 is here. In between 0 and 1, you need to divide this into 5 parts. You need to divide this into 5 parts, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 parts. In that 5 part, the very first one is 1. So, it is 1 by 5. So, this part is 1 by 5. Moving ahead, this is the part 2 by 5. The next 3 by 5, the next 4 by 5 and the last one 5 by 5 and the last one 5 by 5, right? 1, 0, 1 by 5, 2 by 5, 3 by 5, 4 by 5 and 5 by 5 or 5 by 5 is nothing but 1. So, this is how you need to plot the rational numbers or the fractional numbers on a number line. We'll discuss with more examples. The next question is identify 1 by 3 on a number line. 1 by 3. So, from 0 to 1, divide this into 3 parts. From 0 to 1, divide this into 3 parts. 1, 2 and 3. The first part, second part and third part. So, the very first part will be 1 by 3. The second part will be 2 by 3 and the third part will be 3 by 3. And the third part will be 3 by 3, right? 1 by 3, 2 by 3 and 3 by 3. Okay. So, moving ahead, so this is the value 1 by 3. Moving ahead, let's try to understand Every positive proper fraction lies between 0 and 1. Every positive proper fraction lies between 0 and 1, right? One second, yeah. Positive proper, what do you mean by proper fraction? We discussed that long back. Proper fractions are the fractions where numerator is less than denominator. Proper fractions are the fractions where numerator is less than denominator. Something like 1 by 3. Numerator is 1, which is less than 3. So it is a proper fraction. 20 by 21. 20 by 21. It is a proper fraction. 20 is less than 21. It is a proper. And the fractions which are not proper, we said they are improper fractions. This is a proper fraction. Okay. Identify 1 by 3 on a number line. So 1 by 3, 2 by 3, 3 by 3, and so on. Moving ahead for one more question. Identify minus 1 by 4. So now carefully see here. Here we have a negative number. Don't worry about that. Even the positive or negative, just the orientation, the position in the number line will change, but not the concept, right? So what is the concept? Now, as it is a negative number, we need to take the position in the negative region. The negative region in the sense this is 0, this is 1, this is 2, this is a positive region. But now come back to see in the negative. Let's say this is minus 1. Let's say this is a minus 1. So between 0 and minus 1, you need to divide your region into 4 parts. Between these two, you need to divide into 4 parts, and out of that 4 parts, you need to select the very first part. Okay. So now carefully observe what is the difference between the before and now. Before you used to move towards right, now you need to move towards left. So the very first one we get is a minus 1 by 4. Then minus 2 by 4, then minus 3 by 4, so 4 parts, 1, 2, 3, 4, and this minus 1 is nothing but minus 4 by 4. Minus 1 is nothing but minus 4 by 4, right? So minus 1 by 4, that is the very first point. This position is minus 1 by 4. Always a proper, whether it is positive or negative, it always lies between 0 to 1 or 0 to minus 1. Okay. Every negative proper fraction lies between 0 and minus 1. Every negative, this is the negative. A negative minus 1 before. Every negative proper fraction lies between 0 and minus 1. Lies between 0 and minus 1. Okay. So moving ahead for the next question. Identify 9 by 4 and minus 6 by 4 on a number line. 9 by 4. Okay, I'll just give you a small hint. 1 by 4, 2 by 4, 3 by 4, 4 by 4 is 1. 5 by 4, 6 by 4, 7 by 4, 8 by 4 is 2. That means 9 by 4 is greater than 2. 9 by 4 is greater than 2. In the same way, minus 6 by 4. Okay, minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4 is minus 1. And the number is moving ahead in that direction, which is minus 6 by 4, right? So now tell me how to draw this one. 9 by 4 is a value greater than 2. I know that. It's a value greater than 2. So 0, this is 1, this is 2, and after 2. Now, every 1 unit you need to divide into 4 parts. Every 1 unit you need to divide into 4 parts. Let me write that once again. So 1, 2, 3, 4 parts. 1, 2, 3, 4 parts, and the next 1, 2, 3, whatever it is after that. The very first one is 1 by 4. Next 2 by 4, 3 by 4. 1 is 4 by 4. Next 5 by 4, 6 by 4, 7 by 4. 2 is 8 by 4. And finally, this is the value where we get a 9 by 4. Where we get 9 by 4. It's very simple. Okay. What is the denominator for? You need to break 0 to 1 into that many parts, and you need to plot properly 1 by 4, 2 by 4, 3 by 4, 4 by 4, so on till 9 by 4. Next one. Minus 6 by 4. Minus 6 by 4. Again from 0 to minus 1, which is minus 4 by 4. But still we need to have minus 6 by 4. So here we have minus 5 by 4. And here we have minus 6 by 4. Between 0 to 1, you need to divide into 3 parts. With 3 lines, you need to divide into 4 parts. So this is a minus 1 by 4, next minus 2 by 4, next minus 3 by 4, and minus 4 by 4. So this is how you can plot all these points on a number line. On a number line, right? A very simple approach, very simple questions. Identify 9 by 4 minus 6 by 4, the same question again. Identify minus 5 by 4 on a number line. Minus 5 by 4. I told you minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4. This value is minus 1, and after that we have minus 5 by 4. So it is not in between 0 to minus 1. You can carefully see 5 by 4 is an improper fraction. 5 is greater than 4. It is an improper fraction, right? So 0. Now come back to minus 1. Minus 1 and divide this into 4 parts, 1, 2, 3. The very first one is minus 1 by 4, the next one minus 2 by 4, next minus 3 by 4, minus 4 by 4, and after that you will get one more number of the same distance, which is a minus 5 by 4. Minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4, and minus 5 by 4. Right. So let's try to discuss some more applications based on all this. Identify 5 2 by 3 on a number line. 5 2 by 3, it's very easy that it is actually 5 plus 2 by 3. It is actually 5 plus 2 by 3. That means you can go after 5. You need to divide after 5. 0 is here. Let's say 5 is here. After 5, you need to write the fraction. You need to plot the fraction 2 by 3. So after 5 to 6, divide this into 3 parts. Divide this into 3 parts. So 5 1 by 3, and the next one is 5 2 by 3, and the next is 5 3 by 3, which is 6. Okay, so 5 1 by 3, 5 2 by 3, and 6, or you can write it like this: 5 3 is 15, 16 17, 17 by 3. Okay, 17 by 3. So you divide it 3 parts, 1 by 3, 2 by 3, 3 by 3, so on till 17 by 3. Whatever it is, you get the same answer. This is the position 5 2 by 3. This is the position of 5 2 by 3, correct? Okay, so moving ahead for the next question. 5 2 by 3, just now we discussed, right? So 5 2 by 3, fraction lies between 5 and 6. It is actually 5 plus 2 by 3. 5 plus 2 by 3, so it lies away of 5 and before 6. Between 5 and 6, that number will appear. Okay. Select the second line after 5. Make 3 parts between 5 and 6, whatever we have discussed, right? So take a number line. Number 5 will be here, 6 will be here. After 5, you divide into 3 parts, so that 1 will be 5 1 by 3. Next one is 5 2 by 3, and the next is 6. So 5 2 by 3 is a number very near to 6, which is greater than 5 but less than 6. Right? So moving ahead. I think 5 2 by 3 lie to the right side of 32 by 6. Okay, we have something more to discuss here. 5 2 by 3. 5 3 is 15. 15, 16, 17, which is 17 by 3. And this is 32 by 6. 17 by 3 and 32 by 6. Now, to compare the numbers, try to make the denominator same. So, you maintain into 2 by 2. So, 17 2 is 34 by 3 2 is 6, comma 32 by 6. 34 by 6, comma 32 by 6, correct? 34 by 6, comma 32 by 6. Now, which is greater, which is smaller? Obviously, 34 by 6 is greater. Obviously, 34 by 6 is greater. If you take a number line, the first 32 by 6 will come, and after that, 34 by 6 will come, which is 5 2 by 3. Which is 5 2 by 3. Now tell me what to do here. 5 2 by 3 lie to the right of 32 by 6. 5 2 by 3 lie to the right of 32 by 6. Yes, that is correct. Right side, this is right? So right side of 32 by 6, you can say that yes, it is correct. Yes, whatever the information is given is correct. Okay. Moving ahead for the next one. I think minus 2 lies to the left of minus 3. On a number line, this is 0, we have minus 1, then we have minus 2, and then we have minus 3. Negative numbers, you should be very careful. I think minus 2 lies to the left of minus 3. No, minus 2 lies to the right of minus 3. To the right, see, just with the right and left, the way that numbers got varied. So we can say that no, it is not correct. Whatever the information is given is not correct. Right? Okay, the next one. A number is said to be a rational number if it can expressed as p by q, where q is not equal to 0 and p and q are integers. If a number can be expressed in the form of p by q, where that denominator q is not equal to 0, such type of numbers we can consider them as rational numbers, provided p and q are integers. Provided p and q are integers, right? So moving ahead, set of rational numbers is denoted by q. Set of rational numbers is denoted by q. Remember what is our natural numbers? Natural numbers n, whole numbers w, integers z, right? In the same way, q for rational numbers. And after rational, you will learn something called irrational. In higher standards, as well as the real numbers, complex numbers, imaginary numbers, right? So there is a long chain with all the numbers. Okay, so moving ahead, what is the equivalent rational number for minus 15 by 36 with the denominator 12? Minus 15 by 36, let's try to divide with 3. Let's try to divide with 3. 3 1s 3 5, so minus 5 by 3 1s 3 12, so 36. So what I can say, okay, so with the denominator 12, minus 15 by 36 and minus 5 by 12 are equivalent rational numbers. Although their appearance is different, the numbers are different, but they are numerically equal. They are equivalent rational numbers. They are equivalent rational numbers. The next one, numerator is minus 75. Minus 15 by 36, so multiply into 5 by 5, minus 15 into 5. Minus 15 into 5 is minus 75 by 36 into 5. 36 into 5, 6 5 is 30. 5 3 is 15, 16, 17, 18. So minus 75 by 180. Minus 75 by 180. So the equivalent rational number for minus 15 by 36 is minus 75 by 180. Okay, so moving ahead for the next question. So what is the equivalent rational number for 12 by 25 with the denominator 75? We have 12 by 25, just multiply with the 3 in the numerator and the denominator. That will give you 12 into 3 in the numerator. 12 into 3 is 36 by 25 into 3 is 75. By 25 into 3 is 75. So with the denominator 75, the equivalent rational number for 12 by 25 is 36 by 75. 36 by 75, right? What is the next one? Numerator 48. We have 12 by 25. So into 4 by 4, the numerator will give you 48. The denominator 25 into 4. So please try to do that. 25 into 4 is 100. So that is how you can try to solve that. 12 by 25 is equal to 48 by 100. Okay, so moving ahead, going forward, every integer is a rational number and vice versa. Every integer is a rational number. Yes, every integer, let's say 2, 3, 4, 5, minus 1, minus 2. All these are rational numbers. But, okay, minus 1 by 2, which is a rational number, but not an integer. Not only negative, even the positive, 1 by 2, minus 1 by 2, all the fractions are rational numbers, but which will not come under integers, right? So every integer is a rational number and vice versa is not correct. Then we can say that no, it is not correct, because you can see some examples which violated the given conditions, right? So moving ahead, in a rational number of the form p by q, okay, rational number of the form p by q, q must be a non-zero integer. Yes, exactly correct. In p by q format, q should be not zero. Q should be not zero integer. Yes, when we are talking about rational numbers, both numerator and denominator should be integers, right? And in integers, it should not be zero. In a rational number of the form p by q, Q must be a non-zero integer. Yes, that is exactly correct. It should be a non-zero integer, right? That means it cannot happen 0 because if it is 0, the denominator gets 0 and becomes undefined. It gives you undefined, right? So let's try to discuss more about this one. 5 by 7, 6 by 7, 7 by 7 are equivalent rational numbers. No. Equivalent means they should be equal in values. No. 5 by 7, 6 by 7, 7 by 6 are three different values side by side, but they are not the same. We say that answer is no. Answer is no, right? So moving ahead, I hope you understood all these topics about rational numbers. We discussed about first of all fractions, and then we discussed about decimal numbers, and then we came to rational numbers, right? I hope you understood all this. In the coming class, we're going to discuss more applications on all these topics, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone, welcome to chemistry class at Gravity Cloud. Let's continue our journey of chapter of water, too little to waste. Now in the last class we had gone through all about the water, right? So many things were done regarding the water, its chemical properties, its physical properties, as well as the pollution caused on the water bodies by different factors we have covered. In this class, we try to cover this chapter by going through the topic of drinking water and solubility of gases. Once we are done with this thing, then we'll try to solve some questions, and with this chapter will be closed, right? So let's start it. Now when we talk about drinking water, have you ever imagined that how do we get the drinking water so pure? When I say so pure, that means the water which you get to drink, it passes through three different stages, right? So the water which you consume, it passes through the stage of preservation. It passes through the stage of preservation, then cleaning, and then supply. So when I say preservation or when I say cleaning and supply, what does that mean? See, all the water which we drink, it has different resources, right? It can either be well water, or it can be pond water, or it can be lake water. So the water which we drink, it can either come from well or from pond or from lake or other different resources, right? But the thing is how the water get replenished. In these resources. If every year, if every day you keep on using the water from lake, pond or well, the water will go down. The level of water will decrease, right? But then how that water gets replenished? It is because of the rain. This replenish occurs, or we can say replenishment of these resources of water. It occurs because of the rainwater, right? So the rainwater, it comes, it falls in these ponds, lakes, well, and it replenish the water. It replenish the water resources. So in that way, we will understand how the preservation of water is done. So basically what happens, that reservoirs, we have the water reservoirs. The reservoirs like lake, just like I told you, ponds, or even the rivers, these are actually the water reservoirs. So what happens, these reservoirs, they are used for the rainwater collection, right? The ponds, the lakes, they are used for the rainwater collection. And what happens, when the rain comes, the water gets collected in these regions, and then we use that region or we use that water for the further use, right? So these reservoirs, they collect the water. This water is collected and sent to the reservoirs through the channels or rivers. For example, there is a river flowing here. Right, this is a river flowing here, and some distance away, this is the water reservoir. right? So what will happen? When the rain will fall in this river, when the rain will fall in this river, what will happen? The water will get collected, right? This water will pass by using the drains, by using the drains or by using the canals, by using the canals or drains, we pass this water into the water reservoir, right? These water reservoirs, what will happen in these water reservoirs? Heavy particles of the dirt, they will settle, simple, and we get the little clean water. So what happens when this water comes in the rivers? The river water is usually muddy, right? The water will be muddy, M-U-D-D-Y, muddy, means the water contains the mud particles. This water, this will be stored into the reservoir, right? In the reservoir, what will happen? Sedimentation will happen. In the reservoirs, sedimentation will take place. In sedimentation, what happens? In sedimentation, the heavy particles, the heavy stone particles, heavy sand particles, mud particles, or any other foreign particle, it will settle down, right? So all the particles, they will settle down at the bottom of the reservoir. They will settle down at the bottom of reservoir like this, right? So what do we get at the top? At the top here, at the top area, we get the relatively clean water. We have not get yet the pure water. We get just the clean water, right? So this is how the preservation is done. This is how the preservation of water is done. You get the water from the rivers, canals, lakes, ponds, and just pass it into the reservoirs. In the reservoir, the water will settle down, the heavy particles will settle down, sand will settle down, gravels will settle down, and at the top, we get the relatively clean water, right? This is how the preservation is done. Once this preservation is done, once we preserve the water, then we do the cleaning of water. When I say cleaning of water, that means what? That means, see, same thing, right? Here also the rainwater is coming, the rainwater is falling on the rooftop, and from the rooftop it is getting collected here. It is getting collected into this big jar or big container. So there are different ways we can preserve the water. Either we can collect the rainwater into the big ponds, or we can collect the rainwater from the rooftop. So these are the different techniques of preserving the water, right? So once the preservation of water is done, once the preservation of, just a second, yes. Once the preservation of rainwater is done, then what do? We do the cleaning of water. So when I say cleaning, cleaning means what? In the cleaning of water, sediments removed from the solid particles that settle down. In the cleaning of water, all the sediments which are removed, they are taken out, right? And we get the clean water. Then we do the filtration. So basically what happens, suppose here, you get the water from the river, right? We pass it to the reservoir. We get the water from river, we pass it to the reservoir. In the reservoir, sedimentation occurs. So the big particles, they settle down. Then this water is taken from here and pass it to the filtration. Right? Here you see we have sand at the bottom. We have the sand at the bottom. This water will pass through the sand. This water, it will seep. It will seep into the sand, and from here it will collect it into this tank. This water will be collected into this tank, right? In this tank, what will happen? We will put some amount of chlorine. We will take some amount of chlorine from here and the water we are getting from here, right? The water will mix up with the chlorine and chlorination will take place. Chlorination will occur. Now when I say chlorination, that means chlorination is a process in which we kill the harmful bacteria, harmful germs, or harmful any kind of particle which is present in the water, right? So sedimentation removes the big particles, filtration removes the small particles, and chlorination, it removes the insects, germs, or any kind of bacteria. So whatever water comes out of it, whatever water comes out of the chlorination tank, it is passed to the supply. it is passed for the supply. Now when I say passed for supply, that means it is passed to the homes or schools or any other area where we use the clean water, right? So you can directly or you can easily drink the water which we obtain here. Whatever water we obtain here, we can easily drink here, right? So this is how what happens. Take the water from the river, pass it to the reservoir. In the reservoir, the big particles or the gravels or heavy particles, they will settle down. So the water which is coming from the top, it is taken and it is passed through the sand. Here the filtration will occur. Filtration will remove the further smaller particles. Filtration, it removes fine particles. It removes fines. Filtration remove fines, right? Fines means very small particles. Then the water which we get from the bottom, it is taken into this tank. Chlorine is taken from here. Both are mixed up and chlorination occurs. Because of chlorination, what will happen? The harmful bacteria will be killed, right? Chlorination kills the bacteria. So once the chlorination is over, then we get the water through the taps. And this is how we can easily get the pure water, right? So there are 3 steps. First step, preservation. Second step, cleaning. And third step is the supply of water, right? So if you want to note it down, I give you 10 seconds, just note it down. Okay, chalo. Next important is regarding the solubility of water. Now I told you that water, it has the solubility capability, or we can say the gases, they can easily get dissolved in the water. So have you ever seen the Coca-Cola bottle or Pepsi or any kind of cold drink bottle? When you open the bottle, what happens? A gas comes out, right? What is that gas? Basically that gas is actually the CO2, carbon dioxide dissolved in water, right? So whenever you have the carbonated drink you can say, or you can say the soda bottle, or you can take any soda bottle. In the soda bottle, what happens? The water is there and the carbon dioxide is also there, which is dissolved in water, right? And this is the cap. So when you remove the cap, what will happen? This gas will come out. The bubbles of gas will come out. So if the bubbles are coming out, that means what? That means the gas was soluble in water, right? When there was a cap, the gas was actually soluble in water. But the moment you remove the cap, what will happen? The gas bubbles, they will come out, right? These gas bubbles, they will come out like this. Simple. What did we do? In this case, when you had the cap, when the cap was there on the surface of bottle, just a second. Yes, here we have the cap, right? When the cap is there on the mouth of bottle, the gas is inside the bottle, right? And the gas is dissolved in the bottle. In that case, the bottle is under high pressure, right? This liquid or the gas which is present here, it is at the high pressure. But the moment you open the cap, the moment we open the cap, what will happen? The pressure will reduce, right? The pressure inside will reduce and the gas will come out of the bottle. Simple. So the pressure releases and the bubbles appears. When you open the bottle, what will happen? The pressure releases and the gas will come out of the bottle. So what can we conclude from this statement? What can we conclude? We can say that at higher pressure, gases are soluble in water. I can say this thing? Yes, because here in the case of first bottle, the cap was not removed and the water inside the bottle along with carbon dioxide were at high pressure. That's why this gas was dissolved. But the moment you remove the cap, the water comes out, the gas comes out, right? Because the pressure released. The moment you remove the cap, the pressure released and the gas will come out. See, this is the same just like the balloon. You inflate the balloon, what will happen? Its size will increase. And you just press the mouth of balloon. Just keep on pressing the mouth of balloon. The gas will not come out, right? And inside the balloon, there will be huge pressure. But the moment you open the mouth of balloon, what will happen? The gas will come out. Same is the case with here. The gas is there in the water. The gas is dissolved in the water in the first case. But the moment you open the bottle, the pressure will decrease and the gas will come out. So I can say that under high pressure, gases are soluble in water. And at low pressure, the solubility decreases. Right? We can say that at low pressure, solubility of gas in water decreases. Right? This was the case of carbon dioxide. What about oxygen? Now all the aquatic living organisms, like we can talk about fish, frogs, or we can talk about any other sharks, whales, dolphins, crabs. All these are the aquatic animals, right? How do they breathe? To survive they need oxygen. But how do they get oxygen? The fish, the dolphins, the sharks, the whales, they always remain inside the water. But then how do they survive? Because the oxygen gas is soluble in water. O2 is soluble in water. So in the water, the oxygen is already dissolved, right? Because of the presence of dissolved oxygen in the water, the fish can survive. They can take the oxygen from water. Similarly, there are other examples, right? Similarly, like we can talk about sharks, whales, dolphins, crabs. They can also take the oxygen from the water because it is dissolved in the water, right? So all I can say is that the effect of temperature as well as the pressure. We can discuss about the effect of temperature on solubility of water and effect of pressure on the solubility of water. About the pressure, we understood that if you increase the pressure or if there is a high pressure, the solubility of gas increases in water. And if you decrease the pressure, the solubility of gas will decrease. Same is the case with temperature. On decreasing the temperature, or we can say on increasing the temperature. If you increase the temperature, solubility of gas will decrease. Simple. So the solubility of gases will decreases with the rise in temperature. Simple, right? So increase in temperature expels the gases dissolved in the water. Simple. So we can do one thing. Let's suppose we have the water. This is my beaker, right? Let's say this is my beaker which contains water. Right? Let's say the oxygen is dissolved here. It has dissolved oxygen. This water has dissolved oxygen. Right? And let's say it is 20 gram per liter. Or we can say, let's say it is 5 gram per liter. That means in 1 liter of water, 5 gram of oxygen is dissolved. Right? We can say in 1 liter of water, 5 gram of oxygen is dissolved. Now I will do one thing. I will heat the beaker from the bottom. I will heat this beaker from the bottom. Let's say I am heating it by using the Bunsen burner. Right? This is what I am doing. I am using the Bunsen burner and I am heating this beaker from the bottom. You will see the water will boil. After some time the water will boil and the oxygen concentration, the concentration of dissolved oxygen in the water will reduce to 3 gram per liter. Initially it is 5 gram per liter, but when I heat the water, the dissolved oxygen concentration in that water reduced to 3 gram per liter. So what is happening? On heating the water, the gases are expelled out. Right? On heating the water, the gas is expelled out. So, or we can say, on heating the water, the solubility of gas in the water decreases. In this case, we have 5. Upon heating, it reduced to 3. Simple. Understood? Just note it down if you want to. I give you 10 seconds. Yes. So we have this beaker which contains dissolved oxygen, right? 5 gram per liter. I heated it. On heating, what happens? The gas is removed. The gases came out. Which one? Dissolved oxygen. And the solubility remained to be 3 gram. Right? So the solubility of gases in water decreases with the rise in temperature and increase in temperature. When you increase the temperature, it expelled the dissolved gases in the water. Simple. Second case is regarding the pressure. When I talk about pressure, I told you increase in pressure on the surface of water. Increase in pressure on the surface of water increases the solubility of gases in water. That is what is happening here. That is what is happening here. The cap is there on the surface of bottle. So the pressure is huge. The pressure is high. That's why carbon dioxide is dissolved. But the moment you remove the cap, the pressure reduces. When the pressure reduces, solubility decreases. Right? So, solubility of the gas in water decreases with the decrease in pressure. Solubility of gas in water increases with the increase in pressure. And the solubility of water at fixed temperature. Solubility of gas in water at fixed temperature can be understood by Henry's law. So Henry's law is a law that tells us about the how gases are soluble in water. Simple. Right? Henry's law tells us about how the gases are soluble in water. So this value is equal to what? According to Henry's law, the pressure of gas in water is directly proportional to concentration of gas in water. Remember this thing. The pressure of gas in water is directly proportional to concentration of gas in water. Understood? The pressure of the gas, whatever pressure is there, right? Whatever pressure we have of gas in water is directly proportional to concentration of gas in water. That means if the gas is more in water, it will have more pressure. If the gas is less in water, it will have less pressure. Simple. Right? So two things we have understood about the solubility of gases in water. One, with respect to temperature. Second, with respect to pressure. In temperature, the solubility decreases with the increase in temperature. And in the case of pressure, the solubility increases with the increase in pressure. And the solubility of gases in the water at fixed temperature is understood by Henry's law. Right? So this is all about the solubility of gases in the water and regarding the drinking water facilities. Right? In the next class, we do one thing. Next, we have the questions. So in the next class, we try to solve the questions. And once we are done with the questions, we will be done with the chapter. Right? So that's all for today. I hope you understood everything properly. Right? One thing I want to tell you here. Suppose we have the pressure P1. We have the pressure P1 over the surface of water. This is the water and this is the gas. This purple color is the gas. Purple color dots are the gas and this is the water. Right now P1 pressure is there. I do one thing. I increase the pressure. I increased the pressure over surface of water by pulling the piston down. You see these gas particles, they are more soluble in water. Right now how many? 1, 2, 3, 4, 5, 6. 6 particles are soluble in water. On increasing the pressure, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 particles are soluble in water. So increase the pressure, increases the solubility of gas in water. Simple. Right? So that's all for today. I hope you understood everything perfectly. Next class, go through the questions, and with that we're done with the chapter. So I hope you enjoy it pretty well. Thank you.